Welcome back to your math class. This is 10.5, Rationalizing Denominators. Remember in an earlier lesson we talked about we could not have a radical in the denominator. And what we saw then is that everything we dealt with could be simplified so that we did not have a radical. But what happens when we have something like the square root of 9 over the square root of 37? See, 37 can't be simplified. It's a prime number. So this is where this rationalizing thing comes in. What we're going to do is we're going to multiply both parts by the square root of whatever's in the denominator. Now remember, I mentioned this the other day too in one of our videos, that when the top number and the bottom number, the numerator and the denominator are the same, that equals 1. So I'm not changing the value of the fraction that we started with. I'm just going to change the appearance to something that we can work with and that is acceptable as an answer. So remember what we said, in 10.4b and others, the square root of a number times the square root of the same number, it equals that number. Now in the numerators, I can take the square root of 9 and then times the square root of 37. And this is simplified. I can't simplify it anymore. The square root of 37 and the whole number 37 are not the same. I can't cross them out and say that's 1. So you just want to keep that in mind. What's under the radical is a much smaller number than what we have here. If you think about it, this is very close to 36, and the square root of 36 would be 6, which is a much smaller number than 37. So they would not cancel each other out or simplify. Remember also from a previous lesson, we talked about if we have a number, a fraction underneath the radical, we can separate it like this. Or if we start like this, with them already separated, we can put them under the same radical if that helps us simplify it. For this, we need it to be separate like this, and then we will come in and multiply, rationalizing that denominator, and then we will continue with the multiplication, and then there is our answer. And again, the square root of 6 is not the same number as the whole number 6, so this cannot be simplified anymore. Let's look at what happens when we have a cube root. For this one, we have to remember, the cube root of, well, we looked at that earlier in that 10.4b, so I'm not going to go there again. We'll have to do this twice so that we end up with 3 of these, okay, because of that cube. And remember, we're doing 1, and so we have to be sure and do the top is the same. So when I look at this one, then I'm going to end up with, at the bottom, I'll end up with 5. The cube root, 5 times 5 times 5 is 125. The cube root of 125 goes back to the 5. The 2 is still on the outside. And then we have the cube root of 5 times 5, 25. Everything is simplified, and so this is our answer. Alrighty, this one's a little bit different because we've got, in the denominator, we do have a square root that we could simplify part of it. I can take the square root of 9, so I want to do that first. And then all I'm rationalizing here is the x. And so now we can take and multiply times the square root of x. To finish our answer. The next few problems are going to be a little bit different. We're still rationalizing, but we don't just have single terms. We have two terms. And what we're looking at here is we're rationalizing with the conjugate. Now this is a word that reminds me of English class. When you have to conjugate verbs, maybe in a Spanish class where you're conjugating verbs. So remember, at the introduction of, I think, 10.4b, I reminded you of how when we did with the same numbers, the same numbers first and second with that minus and the plus. This is the factors for the difference of two squares. And what will end up happening is the middle term will cancel, and that's what we want to happen here. So notice the conjugate is exactly the same, except this is a plus and this is a minus. That is what makes it. All right, so let's focus on one thing at a time. Let's look at the top. So we have the square root of 5 times the square root of 5, which is going to give me 5. The square root of 5 times a negative square root of 2. So I'll have a negative square root of 10. Then we want to take the negative square root of 2 and do the same thing. So negative square root of 2 times the square root of 5. Negative square root of 2 times a negative square root of 2. Negative times negative. And the square root of 2 times the square root of 2. And then we'll simplify that in a minute. Here, I'm not going to do the middle terms. I've already seen. I've done it. I've shown it to you. You've practiced with it. The middle term will cancel here. So the square root of 5 times the square root of 5 is 5. A plus times a minus is a minus. Square root of 2 times square root of 2 is 2. Then we can come through and simplify everything. So in the numerator, we've got 5 plus 2. We have 1 here and 1 here. At the bottom, 5 minus 2. And again, it looks like a number that's not really finished, an answer that's not done, but it is. When you have three terms that you're looking at here, I've got 1, 2, 3. To simplify, all three have to be divisible by the same number. So let me just make a note here. Okay, To simplify, all three terms must be divided or divisible by the same number. So here's our problem to start with. We want to multiply by the conjugate. So that's 1 plus the square root of 3, numerator and denominator. Then we can start doing our multiplying. At the top, we're multiplying 4 times 1 and 4 times the positive square root of 3. At the bottom, I have 1 times 1, negative times positive, square root of 3 times square root of 3. And remember, I know I can do it that way because of the difference of two squares. I know this is the answer to the difference of two squares. So we can finish this out. Alrighty, I can simplify this one. So let's look at a couple of ways to make this happen. Okay, I'm going to go ahead and put simplify, and then we're going to move up here. All right, so notice 4, 4, and 2 could all be divided by 2. And so I've got a couple of ways to look at this. Let me show you the way that my math lab prefers it. Okay. Here you notice I have a GCF of 4. So let's pull out the 4. This is all over a negative 2. The negative, so now I'm going to take these two. This has been factored, so now I'm just looking at reducing these two. And so 4 divided by a negative 2 would give me negative 2 times 1 plus the square root of 3. Okay, so like I said, this is the answer that my math lab prefers. You could also look at it this way. Is I have a 4, negative 2, and they can all be divided by that 2. So 4 divided by negative 2 would be negative 2, and then this 4 divided by negative 2 times the square root of 3. And so this is another answer. And if you look at this, negative 2 times 1 gives us the negative 2. Negative 2 times the square root of 3 is right here. So either of these answers are correct. My math lab prefers it factored. For me, on a test, if I were doing a paper test, I would take either answer. But I'm giving you my math lab preference so that when you do the homework or take the test, you'll be sure and put it in the correct format. All right, let's do one more before we do some practice. So here's our problem, our conjugate, 5 times the square root of a plus the square root of b in both locations. Then we want to take and multiply. Again, we're foiling. So the square root of a times 5 times the square root of a. So those a's are going to become, those square root a's are going to become an a. Square root of a times the square root of b. Positive 1 times 5 times the square root of a. positive 1 times a positive square root of b. At the bottom, we are going to multiply, but remember, everything's the same except that minus and that plus, which means no middle term. So 5 times 5 is 25. Square root of a times square root of a minus times a positive, square root of b times square root of b. This is the correct answer. But in my math lab, they put it in order so that you have your a here and then the square root of a. So they're putting in an alphabetical order, plus the b, and then plus the ab. It should take it either way. It should. But in case it doesn't, you might want to refer back to this and rearrange it alphabetically. All right, let's practice. All right, go ahead and pause the video, and when you come back, the answers will be here. Okay, so what I did in this answer, we don't like negatives in the denominator, so all I did was pull it to the front. We could simplify this a little bit more by factoring out the 5s. So you could have a 5 to the outside. I would go ahead and try it this way in my math lab. If it won't take it, then factor out the 5. And so your 5 would be on the outside. You would still have the negative in front. So let me do this. So we could have negative 5 and then 1 minus square root of 3 over that 2. Okay? On this one, instead of putting the P first, I put the N first, just because that's alphabetical order. It really doesn't matter. It shouldn't matter, I'll say that. But, you know, just in case they throw something out there and said that you have the correct answer in the wrong form, sometimes that's sometimes that's the red box you'll get on my math lab. Right answer, wrong form. Then you'll know if you had it on this one, factor out the 5. Here you would reverse the order so that it's alphabetical order. All right, good luck. Hope you guys you're trucking right along. We don't have very many lessons left to do, so that's great.